Hello friends, myself R.D. Mahajan presenting my video on vector calculus revision part 2. First example, if r bar is the position vector and r is equal to absolute value of r bar or mod of r bar, then show that del square of r raised to n is equal to n plus 1, n into n plus 1 r raised to n minus 2. And to prove this, we take the help of that given information. We require to find del square of r raised to n, nothing but del dot del. Del dot del means del square operated on r raised to n. Then it is del dot del of r raised to n, standard result as n r raised to n minus 2 into r bar. Standard result. When we take the help of the standard result, we know this result. We know that del dot f, scalar function f, into another function g bar, vector function, del dot fg is equal to del f dot g bar plus f del dot g bar. We have to use this result, and therefore using this result we try to get therefore that del square of r raised to n as del dot first function n into r raised to n minus 2 is a scalar function and r bar is a vector function. Therefore applying this result, it is del f means del of n r raised to n minus 2 a dot product with r bar plus f n r raised to n minus 2 into del dot g bar means del dot r bar. Then it is equals to, again applying the same result, standard result, del of n r raised to n minus 2 n constant n minus 2 r raised to n minus 2 minus 2 means it become n minus 4 into r bar. This is the del of n r raised to n minus 2, a dot product with that r bar, and plus n r raised to n minus 2, and the standard value of del dot r bar is 3. And then simplifying it, we get n minus 2 r raised to n minus 4 dot product of two same vector r bar dot r bar is r square and plus 3 times n r raised to n minus 2. Adding the power of this to r, therefore we get n minus 2 r raised to n minus 4 plus 2, we get n minus 2 and plus 3 times n r raised to n minus 2. From these two terms I can take that n r raised to n minus 2 common. Therefore n r raised to n minus 2 common. Remaining terms are here n minus 2 and here it is 3 plus 3, and therefore simplifying it we get the required result n minus 2 plus 3 minus 2 plus 3 we get n plus 1, and into that r raised to n minus 2. Hence a result is proved. A very simple problem, only you have to remember standard result. We have to apply that standard result. The first one, del of r raised to n as n r raised to n minus 2 into r bar. Del dot r bar is 3, and this del dot fg as del f dot g bar plus f del dot g bar, and then simplify it. to get the required result. Example number 2, example second, find del dot f bar, where f bar is equal to x by r into I plus y by r into j and plus z by r into k. We require to find del dot f bar. Del is a operator of differentiation operator defined as I dou by dou x plus j dou by dou y plus k dou by dou z, a dot product with f bar, and therefore it is I dou by dou x plus j dou by dou y plus k dou by dou z, a vector quantity, a dot product with another vector quantity, that is x by r into I plus y by r into j plus z by r into k. A dot product of two vectors, as per definition, it is a1 b1 plus a2 b2 plus a3 b3, and therefore performing that dot product, a2 b2, that is dou by dou y of y by r, and a3 b3, it is dou by dou z of z by r, where r is magnitude or mode of that r bar, and therefore it is a function of x, y, z, where r is root of x square plus y square plus z square, and therefore that del dot f bar is equals to differentiating this by quotient, that is r, derivative of x is 1 minus x, and derivative of r with respect to x is dou r by dou x divided by r square. Differentiating that y by r with respect to y, we get, again applying quotient rule, r, derivative of y is 1 minus y, and derivative of r with respect to y, dou r by dou y, and divided by r square, plus differentiating this term with respect to r, we get by quotient rule, r, derivative of z with respect to z is 1 minus z, and differentiation of r is dou r by dou z divided by r square, and we call this as equation 1. Then we require to obtain dou r by dou x, dou r by dou y, and dou r by dou z by differentiating this with respect to x. Differentiating r with respect to x, we get this is nothing but x square plus y square plus z square raised to 1 by 2. Therefore, its derivative is 1 by 2 into x square plus y square plus z square. 1 by 2 minus 1, we get 1 by 2 minus 1. And chain rule, differentiation of these three terms with respect to x, it is 2x. And therefore, x get cancelled, 2 get cancelled, we get that result as x divided by 1 by 2 minus 1 is minus 1 by 2. Transferring it to denominator, we get root of x square plus y square plus z square. And then we can write down similarly the result for the remaining two. Therefore, similarly, that dou r by dou y, we get, when we are differentiating with respect to x, we are getting term of x. When we differentiate with respect to y, we have the term of y divided by root of x square plus y square plus z square. and dou r by dou z as z upon root of x square plus y square plus z square. And then substituting these three values here in this equation 1, we get substituting values of all these three partial derivatives. We have r minus x, the value of dou r by dou x is x divided by root of x square plus y square plus z square divided by r square, then plus r minus y, the value of dou r by dou y is y divided by root of x square plus y square plus z square divided by r square, and plus r minus z multiplied by z upon root of x square plus y square plus z square and whole divided by r square. Simplifying it, denominator is same, therefore we can take LCM as r square. This is r plus r, we get 3r minus x square divided by r square, x square by r, square root of x square plus y square plus z square is nothing but r, minus y square upon r and minus z square upon r. We get 3r square minus x square plus y square plus z square divided by r cube. This is equal to 3r square minus x square plus y square plus z square is nothing but r square and divided by r cube, and therefore it is 2r square divided by r cube, and therefore value is 2 divided by r, or its value is 2 divided by r, nothing but root of x square plus y square plus z square as the answer, or the value of that del dot f bar, divergence of f bar. Divergence of f bar is 2 divided by square root of x square plus y square plus z square. Example number 3, find the value of line integral f bar dot dr bar over curve C along the path y square is equal to x, joining the points 0, 0 and 1, 1, provided f bar is equal to x square I plus y square j. And therefore, to obtain this value of line integral, we try to draw the figure y square equal to x, means this is the parabola symmetrical to x-axis, point 0, 0 and 1, 1. Point 0, 0 is O point and 1, 1 point is A. Join it by straight line, we get a straight line OA. And therefore this is one path from O to A and then A to O. Therefore, first of all we try to find the value of f bar dot dr bar. F bar dot dr bar is equals to, f bar is x square I plus y square j, a dot product with dr bar, it is dxi plus dyj A dot product of two vector is a1 b1 plus a2 b2, and therefore as per that it is x square dx plus y square dy. That is value of f bar dot dr bar, and therefore line integration of f bar dot dr bar over that cos C is sum of the two line integrals, that is line integral over path OA and plus line integral over path AO, and we call this as equation 1. And then we try to determine the value of these two line integrals separately. Along OA, that is a straight line joining the points 0, 0 and 1, 1, passing through origin. Therefore, its equation is y equal to mx. We try to find out the slope. Slope is y2 minus y1, that is 1 minus 0 divided by 1 minus 0. Therefore, the slope is 1 into x. Therefore, we get that equation as y equal to x. Therefore, equation is y equal to x. Differentiating it with respect to x, we get dy is equal to dx. Using this information here in this, and therefore that line integration of f bar dot dr bar along the path OA is line integration of, it is x square dx plus y square dy, but y equal to x, therefore it becomes x square, and dy is dx. And as we have to integrate it with respect to x, we see how x changes over this path. It is from 0 to 1, therefore limit from 0 to 1. X square plus x square, we get 2x square, 2 outside, integration from 0 to 1 of x square dx. It is equals to 2 times integration of x square is x cube by 3 and limit from 0 to 1. Therefore, it is 2 by 3, 1 minus 0, upper limit minus lower limit, and therefore the value is 2 by 3. We call this equation 2. Value of that line integral over the first path, straight line OA. Then we try to find out along AO. Equation is y square equal to x. Differentiating it, we get 2y dy is equal to dx, and therefore substituting that value, we get integration of f bar dot dr bar along path AO as dx. Therefore, x is y square, square of it becomes y raised to 4 dx as 2y dy plus y square as it is and dy as it is. And as we have to integrate it with respect to y, see how y changes. Y changes from 1 to 0, and therefore it becomes 2 times y raised to 5 plus y square and its integration with respect to y between the limits 1 to 0. Integrating individually, we get its integration as 2 times y raised to 6 by 6 and plus integration of y square as y cube by 3. Limits from 1 to 0. 2 by 6 means 1 by 3. Upper limit minus lower limit. Upper limit is 0, lower limit is 1. Again plus 1 by 3. Upper limit Therefore, it is 0 minus 1. Therefore, that value is minus 1 by 3 minus 1 by 3. It becomes minus 2 by 3 as a second value. Adding that to in equation 1, along OA it is 2 by 3 and along AO it is minus 2 by 3, and therefore value is 0. Therefore, in this video I have discussed three different problems on vector calculus. If you like my video, please share it as well as subscribe to my channel, and to receive the notification for my new videos, press the bell icon. Thank you. Thanks for watching.